Let's look at selective discharge. Now, when you have a molten binary compound, so molten ionic compound, let's say NaCl liquid, in the solution you have, in the electrolyte, you have only Na plus and Cl minus. So cation will migrate to the cathode, anion will migrate to the anode. So this one is going to get reduced and this one is going to get oxidized. Now, if you have an aqueous compound, means that you have the salt dissolved in water, means that you're going to have the ions from the salt and the ions from the water as well. So you have Na plus, Cl minus, H plus and OH minus, which is from water. Now, at the cathode, you will have both Na plus and H plus because these are the cations that you have. At the anode, you will have both Cl minus and OH minus because these are the anions that you have. Now, which one will get reduced? Which one will get oxidized? Because you have two of them. So then we have the term selective discharged. So if you have two or more cations, we have to select which one is more likely to get discharged. So you use the reactivity series. Now, the cations of the reactive metals are generally never discharged. And these ions, these cations, are the non-reactive, which are less reactive actually. These are going to be preferentially discharged rather than these cations of reactive metals. So H plus is preferentially discharged over all of these. Ca2 plus is preferentially discharged over H plus and all of these. Ag plus is preferentially discharged over H plus, over Ca2 plus and over all of these. Now, anions. Hydroxide ions are more readily discharged at the anode than any other anion that you have. So if you have OH minus in a dilute solution together with any other anion, it's OH minus that is discharged. So it's going to be discharged and produce oxygen gas and water. However, if we are talking about concentrated solution and you have OH minus together with halide ions, then it's going to be the halide ions that is preferentially discharged. But if you're talking about SO4 2 minus and O3 minus, these are not going to be discharged. So for a syllabus, you're going to be looking at the preferential discharge of either OH minus or the preferential discharge of the halides in concentrated electrolytes. Let's see an example of electrolysis of a dilute substance. When you see dilute aqueous, this means that it's dilute, which means that it's not concentrated. So it will contain water in it. So there's going to be H plus and OH minus, as well as Na plus and Cl minus. At the cathode, you're going to have H plus and Na plus that migrate. Be careful, it's not asking you which one gets discharged, it's asking you which one migrates. So between these two, Na plus and H plus, it's H plus that gets preferentially discharged. Na plus is not going to be discharged in the presence of H plus. So hydrogen is going to get, H plus is going to get reduced, gain of electron, and it's going to form hydrogen gas. And ions that will migrate to the anode, you will have both OH minus and Cl minus. Now, because this is a dilute solution, dilute means that it's OH minus that will get preferentially discharged. This one will get discharged only if it is concentrated electrolyte. So this one, there's a mistake over here. This is oxygen gas. Now, when OH minus is discharged, this one produces oxygen and water. OH minus produces oxygen and water. So if you label this, the positive electrode is going to be the anode. The negative electrode would be the cathode because it needs to attract positive. You have the electrolyte, which is dilute aqueous sodium chloride over here. And at the cathode, you have hydrogen gas. And at the anode, with a discharge of OH minus, you have oxygen gas. As you can see, you have the bubbles of gas being produced at each electrode. Now, when you do electrolysis of concentrated sodium chloride now, concentrated sodium chloride is called brine, and it's obtained from seawater. And electrolysis of brine is used to produce chlorine, hydrogen, and sodium chloride on a large scale. Chlorine is used to make solvents for treatment of water and for making bleach. Hydrogen is used to make ammonia, margarine, and as a fuel. And sodium hydroxide is used to make soap and for the extraction of aluminium. So in here you have concentrated sodium chloride, which means that in the electrolyte you will have Na plus, Cl minus, but you will also have some water. So you will have H plus and OH minus in some amounts. Because you have Na plus and H plus, these will migrate to the cathode, and preferentially discharge is going to be H plus. So at the cathode, you will have H plus getting reduced to hydrogen gas. At the anode, at the cathode, you will observe bubbles. Now, at the anode, you're going to have Cl minus and OH minus that will migrate. But because it's going to be a concentrated electrolyte, it's Cl minus that is preferentially discharged instead of OH minus. So you have Cl minus that is going to produce chlorine gas. So in this case, you observe bubbles and you observe the yellowish green gas, which is chlorine gas. So this is a diagram of the electrolysis. You again don't need to be able to draw the diagram, but you should be able to recognize that at the positive electrode is the anode. So at the anode you have the formation of chlorine, so this is used as bleach. And at the cathode you're going to have hydrogen which is used as a fuel to make margarine. And in the solution, so we are using sodium chloride, concentrated sodium chloride, which contains OH minus and H plus as well. So at the anode, you have chlorine which is being produced, so Cl minus is used up. And at the cathode, you have hydrogen which is produced, so H plus is used up. So in the end, you have Na plus and OH minus which is left in the electrolyte. So Na plus and OH minus, they form sodium hydroxide. The ions left in the solution, this is what produces the sodium hydroxide, which is obtained as a byproduct, which is used to make soap. So these are the three products that you get from electrolysis of concentrated sodium chloride, or which is called brine.